Okay, so here's a little pro tip for handling GL uniform locations. So here's a little example. I've got all these little bad boys. I've got these right here. So color uniform location, which here's the shader, by the way. It's pretty simple. Just an example demonstration, nothing particularly interesting, but look at that. GL get uniform location, and I have to store this in somewhere. Okay, it might be in a different file, and I have to store it in some sort of structure, state, or something, and I have to pass it here. Okay, and it's just I don't want to keep track of this. Okay, and also you may make mistakes, and you might be mad, and you're like, man, is this uniform is not working, and then it's just some stupid reason in a big code base. I mean, it's just some stupid reason like, oh yeah, you forgot to get the uniform location, or you forgot to actually assign it to this variable or whatever. And it's all pathetic, right? So basically, here's a better way. All we're gonna do is we're gonna get all of the active uniforms in a shader program. Okay, iterate through each one of them, get the name of each one of them. Okay, and then put that name as the key in a hat map, and the actual value is the actual uniform location. So it's just going to be something like this: sh get, because we're going to be using stbds. Okay, sh get or hn if you want, but still. We're going to give it the actual uniforms, uniform locations hash map, and then we're just going to give it like color, for example. And then it's going to give it the actual uniform location. So let's do that right now. And what we're going to do is we're going to use two functions, gl get active uniforms. There it is. The thing is, this thing takes an index, so we have to like get how many active uniforms are in shader program, and that's why we can just do get program IV. Here it is. You just give it this, and then in the p name we just give it gl active uniforms. So let's do that right now, and then we're gonna abstract it later. So let's just get rid of this piece of shit, and let's put in a separate scope because we're gonna abstract this later. And all we're gonna do is, first of all, uniform count. Okay, and then we're gonna do get program IV. I'm gonna give you the actual program, gl active uniforms, and then uniform count. It does take in an int, right? Yes. Here it is. So now we have how many uniform counts we have. We can just iterate now. So I equals 0, is less than uniform count, I plus plus. GL gets active and type uniform. So let's go here. So it's going to require the following arguments. Let's just copy this so I don't have to look there every 5 seconds. So GL gets active uniform, the actual header program. I'm going to give it the index, which is I. That's why we're iterating over here. The buffer size, which is for the name, so vector name, we're just going to make it 64 just in case. Well, the 32 is enough. So the buff size, as I said, 64. Let's make it size of name. The length, which is null. The size, which is an int pointer. So the size of the actual uniform. We're just going to make it size, and then the type. Here it is, and then the name. We have right here. So what would be nice is to have a struct containing all this information, just in case we need it. So I'm going to do a uniform location. As I said, name is 64, size is an int, and last but not least, type is GL_enum. And yeah, that's about it. That's all we need. So it's going to be like this. Uniform location. Well, uniform location. And you're just gonna do uniform location that name. Here is the size, which is let's just copy this and paste it here. That's it. What's left now is to put we got all the information we need, right? So, well, except the actual location. Hold on, that's probably important, right? That's like the point of this whole video anyways. Location. There you go. So uniform location dot location itself equals to JIT location. I hate the word uniform location now because of how many times I've said it. And then the actual name, so uniform location dot name. And last but not least, let's put this bad boy into the actual hash map. So let's actually make the hash map entry. So uniform location entry. The key is going to be a string, and the value is going to be uniform. Let's just do this. The uniform location itself. So it's going to be uniform locations. Let's just remove this. We don't need it anymore. Which is going to be this over here. So uniform location entry. Uniform locations. I'm just going to make it equal to null for stbds to know it's uninitialized. The key itself, which is just duplicates the name just in case. Actually, we're not actually free in the name, so it's kind of okay. Who cares? And the actual uniform location struct, and that's it. That is literally it. You can just do this, and now let's actually try this. So here, you can just delete this. I should no that was, oh my god, I messed up my Vim. sh get uniform locations, which is the actual hash map, and then the name of the thing we want. So here it's going to be, okay, what was this? This is the color, and this is the time, right? Yep. We got some, I don't think I didn't even include stbds. Oops. Okay. Implementation. There we go. Okay. No, you're not locations value. God damn it. And last but not least here, let's just go here and give it the actual location. We don't need the type nor the name. Last but not, name undeclared. Wait. Let's put here. Name undeclared. Yeah, no shit. And also here. And there we go. It still works. So now let's actually quote unquote abstract it away. So let's copy all this. Paste it here. And call the functions that, okay, let's just make it return the actual hash map. I mean, like a pointer to it at least. Uniform location entry, get uniform locations. Give it the actual shader program. So uint32, uint32 program. Just program program the actual thing, then quote unquote abstract it. Because this is, pretty useful, and you're going to use it across multiple programs, possibly. Also, let me assert that uniform counts doesn't equal to 0, just in case. And yeah, also, I forgot to uniform locations, which equals to null, and then we're going to return that locations. And here, you're gonna do that. Get uniform locations. Yep. And give it the actual triangle fader program. There we go. We have a struct of all the uniforms we want. So now I can quickly make a uniform, just quickly iterate, just do a quick little uniform vector for, let's say, your mom. Here, just add it. And then when I actually want to do the thing, you can just do here. Actually, no, this is more fitting. I can do a const float your mom equals to 0.5, 0.5. We're going to add 0.5 to this. Here is going to be your mom. And here is going to be your actual mom. Here it is. Last but not least, this is a vector 2. There we go. Works easily. Now you have uniforms. And we could also replace all this bullshit with a uniform buffer, but also I do not want to, deal with alignment. Okay, it's just more annoying having a bunch of uniforms that are gonna hurt anyways. I hope this was helpful, and this source code is gonna be in the description, of course. It's just like a quote unquote professional video, anyways. See you.